What's up, Rother fam? I'm back with another banger of a video over protons, neutrons, and electrons. We've been talking about these subatomic particles. So we're going to talk about these in detail and then get them in our journals. So we had a joke the other day that says, why can't we trust an atom? Because, yes, atoms make... Let me zoom in so y'all can see it real well. We're going to write atoms make up everything. And we're going to add to that. Now, atoms make up everything, but making up an atom, can you show me fingers? How many subatomic particles have we talked about? Subatomic particles. Okay, we've done protons, electrons, and neutrons, okay? So we have 3 subatomic particles in atoms. So atoms have 3 subatomic particles. And we've talked about them the last couple of days. One is the proton. And we're going to write 4 bullet points about the proton. Show me the charge. With your hands, show me the charge. Nice. Okay, so the charge of a proton is positive. So we're just going to do a plus sign like you did your arms. And then the proton is going to hang out inside the nucleus with what other particle? Remember? Proton. Good. So it's going to be positive in the nucleus. Now, scientists use something called atomic mass units when talking about atoms, and protons have 1. Okay, that doesn't sound like a whole lot, but protons are 1 atomic mass unit, and we've touched on it. The number of protons determine, I can't remember if y'all remember, it determine what the element is. So protons determine identity. Protons. Show me again the charge of a proton with your hands. Like this. Thank you. Appreciate it. Okay, so we've got, they're positively charged, they're in the nucleus, 1 atomic mass unit, and they determine identity. All right, y'all said protons hang out with the neutrons, so let's go to neutron. Okay, the charge of a neutron, identity. The charge of a neutron sounds like neutron. So what is the charge of a neutron? Neutral. Okay, so the charge of a neutron is neutral. Y'all said it hangs out in the nucleus with the proton, making up the atomic mass. And the neutron is the same mass as a proton. So we're going to write 1 A M U. So we've got the neutron being neutral. It's in the nucleus, and it has an atomic mass unit of 1. Okay, not to be forgotten are these tiny electrons that are hanging outside the nucleus. And you know how we've drawn Bohr models where the electrons are in a real nice order? Well, the electrons are actually outside moving around kind of like kittens. They would be hard to put down. Okay, so the electron. You've got 4 bullets, just one. Yeah, you've got 4 bullets just so you kind of know. So electrons go like this. Show me your hands. We're going to make our hands into a negative side. Okay? Good. So electrons are negative. Do we allow electrons in the nucleus? No. So we will not allow electrons in this classroom. We'll only have protons and neutrons. All right, this classroom being the nucleus. So we're going to put negative. So they are negative. They are outside. Are they ever allowed in the nucleus?
No.
Thank you.
Never.
Never. Okay, this is how small they are. Show me fingers. What is the AMU of proton and neutron? Okay, good. Okay, take that number and divide it by 2,500. And that's how small an electron is. So if you took that number 1 and divide it by 2,500, that's how much of an AMU an electron is. So super tiny in comparison. And then the last thing, we're going to start talking about it next class. These guys, these electrons, are going to determine reactivity. So they're going to determine reactivity. So they're negative. They're outside the nucleus. They have 1 2,500ths of an AMU, and they determine reactivity. Can you nod your head if I can move on? Okay, thank you. Okay, so read this little quip here. It says, wow. Yeah, so this dot right here, this on this eye, contains about 1 trillion atoms. That's a big wow. And yeah, this eye right here, the dot on this eye contains about 1 trillion atoms. So the last thing we're gonna write is that atoms are mostly empty space. And we talked about how you guys, us in here are protons and neutrons, and that would be just the nucleus. Oh, thank you. That would be just the nucleus. If we had ants, if we had an ant at Lisa's Chicken, an ant at the field house, an ant at the track, an ant at the QT, we would need a few more. That would be the atom. So the atom is small, but the electrons are out there taking up a ton of space.
You put most of them.
I put, thank you. Atoms are mostly. Guys, be sure and hit that like button, smash that subscribe button, and turn on notifications. Bye, Rother fam.